Alright guys, so now we're getting down into the nit and gritty. We're going to start talking about the rational root theorem, how it states that if a polynomial f of x equals a sub n times x to the power of n plus a sub n minus 1, x to the power, I made a typo there, that should say n to the minus 1, where a sub n does not equal 0, has integer coefficients, then every rational zero of f has a form of p divided by q, where p is the factor of a naught and q is the factor of a sub n. And then it says the remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder of r is f of k. So with this, we're going to kind of just take one of these problems and kind of pick it apart and what it all means. To put this in basic terms, a naught is actually your constant, and your a sub n is your leading coefficient. That's really the most important part, is constant leading coefficient. Most people actually want to label your leading coefficient as p and your constant as q because it's alphabetical order, except q is going to be your leading coefficient and p is going to be your constant. And really what they are going to be all of your factors of that number. So let's just kind of dive in here. So we have a problem where it says f of x equals negative 4x cubed plus 15x squared minus 8x minus 3. This is number 13 on the sheet that you have. Really with this, we don't even need to pay attention to this part right here. The only thing we need to really concern ourselves with is to label my q and my p. Fight the urge to actually write this in alphabetical order. And then we need to list all of our factors. So all of our factors for negative 4. So negative 4, we have is 1 and negative 4. Negative 1 and 4. Negative 2, positive 2. And of course, we don't need to rewrite that one. And this is going to be my q. My p is going to be all of my factors of negative 3. Well, that is 1 and negative 3. Negative 3 and 1. Well, whoops. Let's say negative 1 and positive 3. That works better. And then what we're going to do is we're just going to put all of these numbers over, and we're going to create a list of possible zeros for this polynomial. Well, in our formula over here, it says p divided by q. So that's what we're going to do. We're going to do p divided by q. So my p is negative 1, negative 3, negative 1, 1, and 3. We're going to put that over my q, which is going to be negative 2. Let's do this in descending order. So let's do negative 4, comma, negative 2, negative 1, 1, 2, and 4. So you can see this list is going to get pretty big. What we're going to do is we're going to take each number on the bottom and basically set up a fraction with each number on top. So my list is going to start looking like negative 3 over negative 4, comma, negative 1 over negative 4, comma, 1 over negative 4, comma, 3 over negative 4. You will start getting duplicate numbers. We'll clean up our list in a second. So now I've done all 4 top numbers with my 4. So to keep myself sane, I just kind of put a line through it so I know I've done it. Now we'll do it with the second number. So now I have negative 3 over negative 2, comma, negative 1 over negative 2, comma, 1 over negative 2, comma, and then 3 over negative 2. And then I want to put a line through it knowing that I've already done it. And I just keep continuing. Here we go. -3 over -1, comma, -1 over -1, 1 over -1, and 3 over -1. Put a line through it to make sure you get them all. And moving on. I'm going to do, we have -3 over 1, -1 over 1, 1 over 1, and 3 over 1. So 1 is done. Then we're going to do -3 over 2, -1 over 2. We're going to do 1 over 2, and of course then we're doing 3 over 2. Put a line through this one on the bottom and it's done. And then to finish out our list, we are going to do -3 over 4. We're going to do -1 over 4. We're going to do 1 over 4 and 3/4. And then put a line through it. Now we can go back into this section and clean out any duplicates that we have. Any duplicates we have. So here we go. I have, let's see, a -3/4 a -3 divided by -4 is 3/4. So anything that's 3/4 I'm going to cross off. That's a positive 3/4. Believe that's it. Next one I have -1 divided by -4, which is 1/4. So any positive 1/4 I'm going to knock off. My next number is 1 divided by -4, so it is a -1/4. So I'm going to knock those off. My next one is 3 divided by -4, so that is a -3/4, and of course I knock those off. So I'm getting rid of all my duplicates. -3 divided by -2 is 3/2, so I knock those off. -1 divided by -2 is 1/2. I knock those off. -1 divided by -2 is the same thing as -1/2. I knock those off. And then 3 divided by -2 is -3/2, so I knock those off. And we just keep doing the same procedure. Alright, so now I have a list here. But now it's kind of lengthy, so I'm going to use my notation to simplify it and make it a little smaller. What we're going to go ahead and do is we're going to do my curly brackets. I'm going to do plus or minus 3/4. So that takes care of this and this. Plus or minus 1/4. That takes care of this and this. Plus or minus 3/2 takes care of this and this. Plus or minus 1/2. Of course, we have plus or minus 1, plus or minus 3. And that right there is your list for possible rational zeros for my polynomial -4x cubed plus 15x squared minus 8x minus 3. Somewhere in there is a zero. Now the question is, how do we find it? All right, so the way we're going to actually find what these zeros are, we can use the remainder theorem. Basically, it tells us if we evaluate our function, if we do like f of 3/4, this is back to Algebra 1 notation. Well, f of 3/4 is -2.25. Well, that is not a zero because it has to equal 0. So the remainder, if we would actually do like polynomial long division or synthetic long division, would be -2.25. So if we actually evaluate it, f of -1/4, that actually becomes a 0. If we evaluate it, f of 1, that equals 0. If you evaluate f of 3, that is 0. So that actually tells me to be able to factor this, or at least to find my actual zeros, I have my points are negative 1/4, comma 0, 1, comma 0, and 3, comma 0 on my graph. But more importantly, I can write these as x minus 1/4, well, plus 1/4, so we have to change our signs, times x minus 1, x minus 3. Having this right here is going to be our factors that we can actually use to graph. Now it looks a little weird. You can rewrite x plus 1/4 as 4x plus 1 times x minus 1 and x minus 3. And voila, you're actually factored, and you actually find all your zeros. And you actually didn't have to factor it. All these numbers came right out of our list. They're all rational numbers. Now, keep in mind, the reason why we're doing this is to give us a starting point to reduce a polynomial. As we get later on into this, we're going to be reducing the polynomial, and then from there, once we get down to a quadratic, all rules are off. We can use the quadratic formula, factoring, because even when we use the quadratic formula, we'll be able to get our irrational answers. This is just fun stuff. It really, really is.